Welcome to our first lesson in constructions. Today we're going to essentially create an equilateral triangle and a hexagon. Now in doing so, I first need to know how to copy a line segment. So using your compass and a straight edge, we're going to construct a line segment that is congruent to line segment LS that we have here. And we're going to do that from point P. So in order to copy the line segment, I first need to know how long LS is. Now again, we cannot use a ruler to measure this. We have to use a compass and a straight edge. So taking my compass, all right, I'm going to put the pointer at one of the endpoints, in this case point L, and I'm going to extend the compass out until the pencil reaches the other endpoint, in this case S. So I have the L and the pointer on endpoint L. I have the pencil on endpoint S. I'm now just going to take my pencil and make a little arc through S to indicate that I have measured the length of LS. Now again, without changing the size of your compass, we're going to now transpose this over here at P. So if I put my pointer at P and I make an arc, anywhere on this arc that I put a point, from P to that point will be equal to the length of LS. So anywhere I put that point, from P to that point on this arc, will make a line segment that is congruent to LS. So we're using your straight edge, we can do this. Again, it would be in this case anywhere we want it to be. I'm just going to go straight across. But anywhere that we draw from P to the edge of the circle, we'll create a line segment that is congruent to LS. To show that things are congruent, specifically line segments, we usually use tally marks to indicate that they are equal, like so. Take the opportunity now in your packet to construct a line segment from P that is exactly the same length as LS. So do that now, pause the video, and try that on your own. Now, using our ability to copy a line segment, we can construct an equilateral triangle given one line segment here. So first off, make sure you have a note that an equilateral triangle is a triangle that has three sides of equal lengths. So if I have this line segment here, and I'm going to call it AB, just so it's easy to indicate the different endpoints. So I have a line segment AB. Now, if I'm going to make an equilateral triangle, the other two sides must be equal to AB. So, taking your compass, we're going to put the pointer on one endpoint, in this case A. Going to stretch it out to the length of B. And again, I make a little mark there to indicate that I've measured it. Now, if I extend that arc, extend that arc above or below, again, any point on this arc from A will be equal to AB. So if I want to find the exact point here on this arc that's going to make an equilateral triangle, I'm going to, again, without changing the size of my compass, I'm going to flip this and put it on the other endpoint. Again, the compass is already, because we haven't changed the size, already the length of AB. I'm just putting the pointer now at B instead of A. And I'm going to make an arc. Now I'll do this in a different color so it's easy to see. If I do that, I now create two arcs that intersect here. We'll call this point C. Point C is now a point that is exactly the same distance away from A as it is from B. So this is an equidistant point from A and B. So using your straight edge, we can now draw a line segment from A to C. And do the same thing from B and C. And since we know that C is equidistant from both of them, then we now know that this is an equilateral triangle. I can indicate that all sides are equal again by using my little tally marks. Now, when you're doing this, you don't necessarily have to draw the entire arcs, both the red and the blue arcs here. You could just show the intersection part, but you must show that at least that intersection. All the construction marks must be left in your picture in order for you to receive full credit in the construction. So make sure you have at least the intersection and the arcs that are connected to create point C from here. So again, take some time now to pause the video and to try this in your packet on your own. Now moving on, we can construct both a regular hexagon and an equilateral to be inscribed inside a given circle. Well, a couple things that we want to make sure we note first. First off, what does it mean to be inscribed? Well, that means that all the vertices, meaning all of the endpoints that create your polygons, whether it be a hexagon or an equilateral triangle, must lie on the edge of the circle. So they must be on the actual edge of the entire circle in order for the image to be inscribed. All right. So for a hexagon, right, that's a six-sided figure. And specifically a regular hexagon means that all of the sides and the angles are going to be equal. So in order for us to do that, first I'm going to take my straight edge and I'm going to draw a radius inside of this circle. Again, that could be anywhere, but a radius must be from the center of the circle out to the edge. So I'm going to indicate that here. Now I'm going to do it as a dotted line. And I'm only going to do that so it doesn't confuse us with the lines that we're going to make later on. But you can make it as a solid line, which is fine. I'm just doing it for the purposes here on the video. But that dotted line is now a radius. So I'm going to take my compass and I'm going to measure that length. I'm going to go from the center of my circle out to the edge, which is, like I said, the radius. Now I'm going to make a mark here in red, all right, to indicate that length. Now, if you're doing this in your packet with a pencil, most likely it's probably going to be difficult to actually see that mark, but for the purposes of the video, it's easy to see where I'm exactly talking about. You can just draw yourself a point, if that makes it easier, to indicate exactly where you are, okay? Now, without changing the size of the compass, right, you're going to start at a point, and again, it doesn't really matter where, but you're going to start with an A point on the circle. I'm going to use this one here since I just created it. And I'm going to turn my compass until I'm close to the edge of the circle. I'm going to make a mark, like so. I'm going to make it a little arc so that it intersects my circle. Again, I could have drawn the entire arc all the way out here, but I don't need to draw all of it. I just need to show the intersection of the circle. Again, without changing the size of the compass, I'm now going to go to the point that I just created and make another mark that intersects the circle. So I'm just going to, again, turn my compass around this point, and I'm going to draw an arc so it intersects the circle. I'm going to keep doing this, right, until I have a total of 6 points, because in this case, we're making a hexagon. And as I do this, I am trying to be as precise as possible when putting the pointer on the circle. I want to put it exactly as best as I possibly can on the intersection of that arc and the circle, right? If you do this, and then again, as I come around here, right, you should be, oops, I just messed that. I should intersect from where I started from, all right? So the more precise you are, and the more accurate you are, the better that's going to be of your intersection. So now, because we never changed the size of our compass, all of these points are equidistant from each other. So using your straight edge, right, we're going to connect all of these marks on the outside of the circle. Now, just for ease and convenience of here on the video, I'm going to use my line tool, but you're going to use a straight edge to connect all of them. So from each point, I'm connecting my each vertice of my hexagon. And again, if I connect all 6 of those points together, I have now just constructed a regular hexagon. Again, to show that they are all equal in length, I can use little tally marks to show that all of those sides are congruent. Now, to construct a equilateral triangle, it's actually the exact same process as my hexagon here. However, I'm not going to connect all of the points together. I'm going to connect every other point together. Right? So again, pick a point to start with. It does not matter. I'm going to do this in a different color so it's easy to see. Let's do it in green here. So pick a point. All right, so if I start at this point here, I'm going to go every other point. So not next to it, but the second point from there. So I'm going from here to here. I'm going to, again, every other point. So I'm not going to this point. I'm connecting it to this point. And so on to this point here, creating my equilateral triangle. Again, we can use the tally marks to indicate all the sides are equal. But since I used a single mark to indicate the hexagon sides are equal, I'm going to use a double tally mark to show that all the 3 sides of our triangle here are congruent. I'm using separate marks here because it is not necessarily true that this line segment here in the hexagon is the same length as the line segment here in the triangle. And in this case, it definitely is not. But you want to be able to indicate that the difference in those pieces. And if you don't know for sure that they are necessarily congruent, this indicates that at least I know that these 3 are equal and these 6 are equal in length. All right, and that is how you construct both a regular hexagon and an equilateral triangle, both inscribed inside of a circle. Once again, take this opportunity to practice this inside your packet.